Many carbon compounds are invaluable to us, but here we shall see the properties of two commercially important compounds, which is ethanol and ethanoic acid. Ethanol is a liquid at room temperature. It is commonly called alcohol or ethyl alcohol and is the active ingredient of all alcoholic drinks. In addition, because it is a good solvent, it is also used in medicines such as tincture iodine, cough syrups and many tonics. Ethanol is also soluble in water in all proportions. We know that consumption of small quantities of dilute ethanol causes drunkenness. Even though this practice is condemned, it is a socially widespread practice. However, intake of even a small quantity of pure ethanol called the absolute alcohol can be lethal. Also, long-term consumption of alcohol leads to many health problems as we all know. Now, here are two chemical reactions of ethanol. The first one is the reaction of ethanol with sodium. Ethanol reacts with sodium to produce hydrogen gas and sodium ethoxide. The reaction supports the acidic character of ethanol. The second reaction of ethanol is with concentrated H2SO4, that is, ethanol reacts with concentrated sulfuric acid at 443 Kelvin to produce ethylene. This reaction is known as dehydration of ethanol because in this reaction a water molecule is removed from the ethanol molecule and that's why it's called as dehydration reaction. Ethanol, as we all know, is widely used for making alcoholic drinks. It is also used as a solvent in the manufacturing of paints, dyes, medicines, soaps, synthetic rubber, and it is used for making medicines like tincture iodine, cough syrups, tonics, etc. So these are some of the uses of ethanol. Now coming to the second important compound, which is ethanoic acid. Ethanoic acid is commonly called as acetic acid and belongs to a group of acids called the carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. The melting point of pure ethanoic acid is 290 Kelvin and hence it is often freezed during winter in cold climates. Now this gave rise to its name glacial acetic acid. The group of organic compounds called carboxylic acids are obviously characterized by a special acidity. However, unlike mineral acids like HCl which are completely ionized, carboxylic acids are weak acids. Now let's see some of the reactions of ethanoic acid. The first one is esterification reaction. Esters are most commonly formed by reaction of an acid and an alcohol. Ethanoic acid reacts with absolute ethanol in the presence of an acid catalyst to give an ester. Esters are basically sweet smelling substances. These are used in making perfumes and as flavoring agents. On treating sodium hydroxide, which is an alkali, this ester is converted back to alcohol and the sodium salt of carboxylic acid. And this reaction is known as saponification reaction because it is used in the preparation of soaps. The second reaction is the reaction with a base. Like mineral acids, ethanoic acid reacts with a base such as sodium hydroxide to give a salt which is sodium ethanoate or commonly called sodium acetate, plus you get water. The third reaction is the reaction with carbonates and hydrogen carbonates. Ethanoic acid reacts with carbonates and hydrogen carbonates to give rise to a salt plus carbon dioxide plus water. The salt produced is commonly called sodium acetate. Did you know that soaps and detergents are also carbon compounds? Have you ever thought of how soaps and detergents act as cleansing agents or what is the chemistry behind it is? Let's see that now. Soaps are basically long chains of sodium or potassium salts of carboxylic acids. A soap molecule has two parts, a long hydrocarbon part which is hydrophobic, that is water repelling and soluble in oil, and a short ionic part which is hydrophilic, that is water attracting and insoluble in oil. The ionic end of the soap dissolves in water while the carbon chain dissolves in oil. The soap molecules thus form structures called micelles, where one end of the molecule is towards the oil droplet while the ionic end faces outside. This forms an emulsion in water, and the soap micelle thus helps in dissolving the dirt in water, and thereby we can wash our clothes clean. Have you ever observed while bathing that foam is formed with difficulty and an insoluble substance called as scum remains after washing with water? This is caused by the reaction of soap with the calcium and magnesium salts, which cause the hardness of water. Hence, you need to use a large amount of soap. This problem is overcome by using another class of compounds called the detergents as cleansing agents. Detergents are generally ammonium or sulfonate salts of long-chain carboxylic acids. The charged ends of these compounds do not form insoluble precipitates with the calcium and magnesium ions in water. Thus, they remain effective in hard water. Detergents are usually used to make shampoos and products for cleansing clothes. Okay, so now to summarize, the two carbon compounds that are commercially very important are ethanol and ethanoic acid. Soaps and detergents are also carbon compounds which are salts of long chain carboxylic acids, and the two important reactions that we discussed here are the esterification reaction, which is the reaction of an alcohol with carboxylic acid forming a sweet smelling substance called an ester, and we saw the saponification reaction which is used in the preparation of soaps.